Especially because you'd have to do really crazy analytics to know that it's digital. So would they shut down all the phones to shut down all this sort of international traffic? So I think we're going to be approaching that same kind of thing. You know, it's not clear that the U.S. could literally outlaw and enforce it any more than they could make everyone not speed and not smoke pot and do whatever sort of things that are just not enforceable. So you may not be able to buy your home with Bitcoin.
You see now?
But you can probably buy a trip to St. Petersburg.
You just didn't have it on.
After the airfare.
Yeah. Now you can push it.
The other thing that's interesting, I sort of touched on this with mentioning Putin and Kim Jong-un. A lot of people think, are we ready yet?
Almost. We got your screen now, so we're good.
Okay, excellent. A lot of people think that the killer app for Bitcoin is illegal transactions. Selling drugs, prostitution, whatever, guns. That's not really accurate. It's transactions that are not approved by the local authorities. So some of the famous one that I really like is there's a service that pays women who write in Afghanistan who can't open a bank account and can't even get money out of a bank account that they would have without bringing a man with them. So by empowering these women to get paid for their brilliant writing, in Bitcoin, they can now actually buy things and have transactions and get value for their time. And that's not about it being illegal. It's about the local authorities not approving of that activity. But you can take it up extra-nationally. Whatever Putin does is not illegal. Whatever Kim Jong-un in their country, it's not illegal. But they may do things that are extra legal from our perspective that we wouldn't want them to do. So, you know, what France might do, or what the nation state of the United States, or Tonga, or whoever. So it's not that it's illegal, it's that it's outside that context. So again, I don't know how they're going to react to these threats to their power base, but these are all part of what's going on. I mean, some of this, quote unquote, I feel like some of it's fear-mongering. It's the same sort of fear people felt when Amazon is putting local booksellers out of business. And how tragic is that? And that's going to destroy the fabric of American society. Well, in Santa Barbara, we no longer have a Borders. We no longer have a Barnes & Noble. We used to have 3 of those. But our little local cool Chaucer's bookstore is still there. Because now they're the only ones. And they get all the business of folks who like to go to bookstores. So who knows where that fear is going to play out. But really, if they can simply move their power base into the next plate, we're good to go?
We're good to go.
Then they'll do that. It doesn't necessarily have to be displacement. It doesn't necessarily have to have guns or dead bodies involved. Not sure you're buying it, but...
I have a follow-up, but I'll wait.
Okay, perfect. Okay, so let me dive into this. I've already asked who you guys are. This is an eye chart. It's not so much meant to read. I also can't really read that. It'll be on the last slide again. Sorry. I like to move. This PowerPoint's available online on my website. So all these links and whatever, you can download later. But this is how I got into the blockchain. And it's through a field of work called user-centric identity, which I've been involved with for about 12 years. This community has realized that the blockchain is an interesting way to provide public identifiers that are not rooted in a public authority. So most identifiers today, they're given to us. State Department gives us a passport number, DMV gives us a driver's license number, Facebook gives us our Facebook ID. There's a movement called self-sovereign identity that uses the blockchain to anchor identity. And I'll talk about that in a little bit more detail, but I'm involved in some W3C committees that are working on this. I write for the People-Centered Internet, and here are a couple of papers that I've talked about it. And I'm a regular contributor in these different conversations. So the co-author, lead author, really, on these 4 papers here. So I came at this from an identity perspective. I happen to be a programmer, C++, JavaScript for most of my career. And because of the opportunity to give a presentation in Santa Barbara, I dove in a little deeper and said, okay, well, what's and then we'll get to some JavaScript. And I'll give you some examples, and we'll do some live coding. We're not going to do a lot. I don't think we're going to have time. But there are some interesting ways that you can use JavaScript, even though I wouldn't recommend it for trying to do mining, for example. Okay, so what is Bitcoin? Okay, it's a cryptocurrency. You can buy stuff with it. Just like any currency, you can exchange it for other currencies on certain markets. That's included up there. It's highly volatile. It's gone as low as 3,000 and as high as 5,000, I think, in the last 2 weeks. Created this thing 10 years ago, and without an IPO, they've capitalized this much value in the marketplace, which is pretty crazy. It is so it's a protocol, but it's also a specific blockchain. And it is the leading permissionless distributed ledger. I'll unpack what that means in the next couple of slides. So what is it not? It's not tangible. I think you can buy little physical Bitcoins. Don't waste your money. And then they're kind of cute. It's not anonymous, as you brought up. It's pseudonymous. So you don't have to give them your name or address or any of the traditional personally identifiable information, but it's a public ledger. So they can follow the transactions. And if it's important enough, they'll follow it all the way down to that Starbucks coffee you bought and go in and talk to the people at Starbucks and say, hey, yesterday morning at 9 a.m., this individual made this purchase. Do you remember anything about him? Right? So what all cryptography does and what all privacy does is it attempts to increase the cost of de-anonymizing, right? We can't guarantee your privacy in any system. There is no such thing as true anonymity. But what we can do is we can increase the number of people you're confused with. So if we know you're male, there are only other 3.5 billion people that could be you, as opposed to if we just know you're a living human, there are 7 billion people that could be you. If we know you're in America, now there are 300 million people. Again, if we know the gender, we can split it down. And so the flip side of that is we can make it very expensive to actually reverse that anonymity or that pseudonymity. So you can buy stuff, but if you do bad stuff, they'll spend the money to come and find you. It's also not purely speculative. And I'll explain that in a little bit. Okay. So blockchain is a technology behind Bitcoin, just like the web is a technology behind Google. And it is a specific way to manage a distributed ledger. There are other ways to do it. And I'm going to unpack how we do it. There are ledgers that are permissioned and permissionless. Permissionless means anyone can participate, anyone can contribute to the consensus mechanism. Some of them, there's a cohort, and only that cohort gets to participate. There are also tons of other blockchains. Some have different rules and APIs. Some actually have the same rules or close enough to the same rules. Some of them even have the same Genesis block, which is what happened with Bcash and Bitcoin and Ethereum Classic. All of these are blockchain. So what's blockchain? I've called it a ledger. How many folks here have taken some form of accounting class, Accounting 101? Okay. So this is sometimes called triple entry bookkeeping. Double entry bookkeeping is what created the modern financial system and how we deal with our accounts in QuickBooks and in pretty much all the corporations in America. And the whole idea is that any given transaction has credits and debits that all balance for every transaction. And that's what we do in the blockchain. So every transaction has credits and debits, and it all has to balance. So this is actual transaction data from my first Bitcoin transaction. It was on the test network, so it wasn't actually my first Bitcoin on the real network. But this account, which has this crazy number, credited $5,000 in Bitcoins. It put 1.1 in my account, and then they got some change. And we paid a fee to the miners of 0.001 Bitcoin. So all this balances. There's a signature, there's a transaction ID, there's some other metadata I didn't include here. But this is basically what a transaction looks like in the blockchain. Accounts, debits, and credits, and it has to balance. So those transactions get organized into blocks. Now, I didn't take the trouble to make these all different. I just copied and pasted. That's that same transaction, but in a real block, these would all be different transactions with different amounts, with different numbers. Today in Bitcoin, each block can have up to a megabyte in transactions. I think that can be approximately 4,000 transactions, give or take. The blocks get signed, and if the account's much balanced. So all of these different transactions, within the transactions, the credits and debits balance, but all of these within the block will also balance. So if I'm trying to double spend from an account, I have an account that has 100 Bitcoin, and I'm trying to buy something from 100 Bitcoin from you and 100 Bitcoin from you. They can't both be in the same block. That would be an invalid block. So that's one of the checks against double spending. So this is a block, mostly. We're going to add something here. We're going to add two things. So every block links to the prior block in the chain. Basically, every miner, as they're mining, is working on the theoretically next block. So if we have 100 blocks, I'm trying to get the 101st block. Now, if I'm the first one to mine that block, then I get rewards for it. I'm going to unpack that more. But they're all linked here. So if I'm working on the 101st, my block will have a link to the 100th, which has a link to the 99th, all the way back to that first Genesis block. So together, this comprises a continuous single ledger of transactions. It's like my QuickBooks account for my company from its entire history. So this ledger goes back 9 years. Approximately every 10 minutes, we add another block. Yes. So it's really vernacular. So I'm going to explain how we mine, and it is something you do within your block that creates Bitcoins. So you're mining and you're getting Bitcoin. It's like, are you mining gold or are you mining the ore? So, what you're digging out of the mine is ore, but eventually it becomes gold. So you could refer to it both ways, and they're both equally right. And part of what's key to this public thing is that anyone can have a copy of this whole ledger. So even if you're not mining, you can look at the accounts and see who has what money, where who is a bunch of numbers. You don't know that it's John Smith. You just know that it's some string of digits. OK, so how does mining work? How does the whole blockchain thing work? So there are two roles. This was a big aha moment for me 2 years ago or whatever when the light bulb went off. There are miners and there are spenders. So if you just want to own Bitcoin or buy and sell things with Bitcoin, you don't have to be a miner. You don't have to run a full node. Miners are the guys who maintain the ledger, and in exchange for that, they get Bitcoins. And I'll unpack that a little bit in the next slide. Spenders simply post transactions. They pay fees so that miners will pick up their transactions. And they don't need to have a copy of the ledger. Might be useful. You might have a limited subset of the ledger, but you don't need the ledger. And because it's public and permissionless, anyone can do either of these roles. But everyone who's working with accounts on the blockchain needs a wallet. And by that, I don't mean the software. I mean a data file that contains public and private keys. Those keys are how you keep track of the transactions. So the address is, I wish I could point to it now, but it's not there. It's on the other slide. The addresses in those transactions were based on the public key that's related to my private key. So if I want to see the transactions that I own, I take the public keys in my wallet, and I can go look at the chain and find out all the transactions related to that account. If I want to spend the money in those accounts, then I use the private key to do cryptographic interaction and prove that I have the authority to spend that money. So if you lose this file whether it's a file or it's on your phone or it's in a database or you print it out on a piece of paper, which I'll give you an example of, this is what controls all your money. And that's where the real security risk is. So if you have a lot of money in Bitcoins, you got to take care of your wallet. OK, so the way the mining works, the way we mine blocks or we mine Bitcoins, Philippe, is every block, it shouldn't say has a hash. It has a nonce. You use the block with the nonce, and you apply a hash against that data set. Who here doesn't know what a hash is? Because I probably need to explain it. OK, so we got one taker. So a hash is a function. In this case, it's the RSA-256 hash. Hash takes in any amount of data you want to throw in it, and you come out with one number. In this case, because it's RSA-256, I'm pretty sure it's a 256-bit number. And the properties of a hash are that it's a one-way function. If you know the hash, there's no way to predict what the content is for it. It also has another interesting characteristic, which is that if you change the data just a little bit, the hash changes a lot. So what mining is doing is the miners are guessing at this extra little bit called the nonce that they add to the transaction, so that when they create the hash starts with a certain number of zeros. How many zeros is the level of difficulty based on the current protocol? So the more miners there are, the more computational power is out there doing mining, coming up with these hashes, the faster you'll find it. And Bitcoin responds to the amount of computational power by making it harder and harder, by making you get more and more zeros. So every time, like John McAfee just announced he's doing a bunch of, he's building a new mining farm. Putin's supposedly creating a $200 million mining farm. Those guys aren't creating the ability to exercise more transactions. They're just increasing how fast the hashes are found and how many zeros then will have to be in this hash.
The hashes they're finding are what already exist in a blockchain, or they're going to be used in a new blockchain?
So the hash is used to prove that you found the magic nonce. So the transactions are provided by spenders. I've got a transaction here. Please put this in the block. Miner says, OK, let me try a nonce with just a 1 in it. Let me try a nonce with 2 in it. Let me try a nonce with 3 in it. They're going to brute force, just randomly guess, until the hash of this entire data set has 5 zeros, 6 zeros, whatever n is at the time.
And I just want to make sure I'm getting it. The hash is based on the data in the block, the transaction
Whoops.
data.
That's right. So a hash takes a large set of input data. It could be a text file. It could be the Gutenberg Bible. It could be an email. And it does math, adds them all up, and outspits a unique 256-byte number for an RSA-256 hash.
So what's the nonce?
So the nonce is the guess of what will complete this. Right? You complete me. This is the quest for the magic cookie that will make the hash generate this many zeros. And this is just there to slow down the miners. So the whole point here is that every 10 minutes, only one person in the world, really should come up with one of these. So we're just making it harder and harder to find the magic cookie. So one person can say, bingo, I got it. I got the nonce. Give me the money. Give me the Bitcoin. This is why it's called proof of work. We're making them work harder and harder. And the way that the math works, it's statistically random. You could guess the nonce on your first guess. I could turn on my home computer, make one guess at the nonce, and get a Bitcoin. Actually, I'd get a bunch of Bitcoins. But it's very unlikely.
So is the way it works that
Yeah, the nonce is inside.
Right.
Yeah, so
Then when you have
the language is unfortunate.
plus the nonce and hash that you get my number 0 in front of the hash. Is that what you're saying?
Right, so the hash is calculated including the nonce. So I say the block has a hash, and then I say you add a nonce, and that's not quite right. The reality is the hash is there. I mean, the hash is based on the nonce and the transactions.
And the nonce is the part that makes it have a certain number 0 that leaves that number.
That's right.
How is it being made harder and harder?
The number of zeros increases. So if I only need to have 1 0, that's relatively easy to find. It's on the order of seconds, I think. If I need to have 10 zeros, then my personal computer would take hundreds of years to do it. But we've got hundreds, thousands, maybe millions of computational units on the planet trying to find this nonce. So every time someone adds new computation, this adjusts. Every 2,000 blocks, they adjust how many ends there are, how many zeros you have to. It's part of the protocol.
So one block creates a hash, which is the magic number, keeps it inside, and the miner basically guesses that number, and then all the transactions in that block is verified?
Not quite. So apologies, this first line I think has led a few of you astray. It's a poor choice of words. The block has the transactions and a link to the previous block that I showed right in this other slide. It also has a nonce. But this, the miner is making up. The miner is guessing this. The link plus the transaction plus the nonce, you can calculate a hash from that. So the nonce is within the data set that you're running the hash against. And so you're guessing that nonce in order to get a certain number of zeros, which is hard to do. It takes time. And as soon as you get one, you basically yell bingo. And so you tell the rest of the network, hey, I got a block. I've got block number 101, because that's the numbering scheme I want to use for us today. And that's a chance to earn Bitcoins. And I'll explain why it isn't guaranteed that you're getting Bitcoins. And you'll get some from the transaction fees that are in here, the 0.001. And the block itself today generates 12.5 Bitcoins. So every 10 minutes, 12.5 Bitcoins are created. Every 4 years, that cuts in half. And by 2140, there will be 0 minted Bitcoins. There will only be transaction fees.
So the nation's putting its supercomputer power behind this. How can the regular miner consist of that?
Yeah, you can't. That's one of the problems, actually, that Satoshi Nakamoto didn't really he didn't talk about in his emails. He clearly had the idea that there's a democratizing role for the individual, but once we had such high value to Bitcoins, it made sense to build out these big farms that were computationally as efficient as possible. And actually, we're going to invest in mining farms as long as marginal benefit equals marginal cost. And ultimately, once capital's invested, it's going to be about the cost of electricity to generate this. So how much electricity does it cost to generate a Bitcoin? Right now, globally, estimates are about $330 million is spent on electricity alone to maintain the blockchain. Okay, so
I was going to ask, would proof of stake kill Bitcoin?
no, because a lot of the question was, would proof of stake kill Bitcoin? And so a lot of cryptologists, cryptographers that I respect, think proof of stake isn't sufficient.
What does that mean?
So proof of stake, there are a number of different types of proofs that people have postulated, and some people are building chains, blockchains that use these different proofs. One of them is called proof of stake. And the way proof of stake works is you prove that you have money in the game. So it's like being a vested landowner gives you the right to vote, which is how it used to be in this country before we had universal suffrage, right? So if you didn't own land, you didn't get to vote. That's proof of stake. So in those networks, you have to show that you've spent 10 grand or 100 grand or whatever to say, yeah, I'm one of the caretakers of this whole network. I'm not going to violate it. But cryptographers think that's crap. or some do. But there are lots of different proofs, and I think for some use cases it might be perfectly valid. But Bitcoin, and I'll explain this a little bit more in a bit. Bitcoin not only has its unique history, it also has a particular set of elegant combinations in its protocol, right? So this consensus architecture that I'm about to talk about, you may not have in a private or a proof of stake architecture. So there are a lot of moving parts, and I would be surprised that any one particular blockchain took over any more than I think it makes sense for any one currency to take over in the world, like fiat currency. It's just not going to happen. Is there another question, or?
So, this is like, if I'm going to try to restate like what you kind of explained to by like following, but is it true that given like some combination of public keys that from each of those transactions in the block, or in that one block, given those public keys and this hash that is produced by combining them in some way, there's like a mathematical property such that only one nonce ties to that hash, and it does so in such a way that like verifies. I guess I'm confused about how it's simultaneously verifying that. Aside from like, I get that it's like a computationally expensive problem,
right?
And maybe that requires like really delving into that particular mathematical property to understand like why does that also verify?
Yeah, so I think I can address that. I would say the question is, how are we simultaneously verifying and yet creating the thing in the same time? Because I seem to have conflated those two, and I think I haven't been clear. So the nice thing about the hash is calculating one hash is cheap and easy. So if someone tells me they have a block, I can very quickly prove whether or not this block with this specific nonce, in fact, has the right number of zeros. It's computationally very, very cheap to test and verify that this is valid. What's hard to do is find the right nonce. You're wandering around in the universe trying to find the rock, and maybe you find the rock, maybe you don't find the rock. But if you hand me the rock, I can say, oh, you got the rock. He's the winner right there. So it's easy to check, hard to find.
So I guess that you can take public keys and combine them in some way to create something which then requires this other input, like a nonce, to match up with that thing. But what does that have to do with, I guess, like verification, other than the fact that it's verifying? It seems like it's verifying this like arbitrary problem.
So yes. And that's why some people will say the fact that we're wasting $300 million in electricity is economically and ecologically a disaster, because you can't see it scaling. So yeah, it is a waste. This nonce is a useless number, except for the fact that you get to yell bingo. It's a completely wasted computational bunch of activity. So you're right. But what it does is it slows down the scope of the auditors so that it's relatively straightforward to figure out who's first, because we want to compensate people for doing the mining. And so let me unpack that here. So this is, went the wrong way. So what if two people both yell bingo at the same time? And same time is on a global network. So what if you have someone in China who finds a good nonce for their block, and someone in Latin America who finds a good nonce for their block? Well, in their communities, they're going to be the first ones. But who was first in North America? Who looks first in Africa or Europe? So this is a global network where satellite delays, the speed of light, all of these things matter in terms of who seems to be first. So there's a really elegant solution, and this is one of the two things that Satoshi really figured out and nailed. And that is that the longer chain wins. So I'm cruising along. I'm trying to get 101, right? I'm trying to get the 101st block. And I hear someone else got a 101st block. I immediately want to stop trying to get the 101st block, because I'll never be the local 101st block. So I'm immediately going to say, great, thanks for that block. And now I'm going to start working on the 102nd block. And that's going to happen for everyone. So all the miners are incredibly incentivized to accept a valid block and add it to the chain. So locally, throughout Asia, boom, they're going to accept that, the Chinese 101st block. Latin America is all going to accept the Latin American 101st block. And it's a race for North America and Europe and Africa. And the way it resolves, nobody is like looking at it and voting and saying, oh, looks like 51% of the miners, because we don't know who the miners are. There's no notion of that. What happens is that the 102nd, there are now two universes. There's the Chinese hemisphere that are working on 102nd based on the 101st from China. There's the Latin America, Europe, and half of Africa, whatever, that's working on the 102nd based on the Latin American 101. Someone's going to come up with a good 102, the 102nd block. And that guy will convince the Chinese hemisphere, look, they got the 102nd. So the whole Chinese hemisphere is going to throw out the Chinese 101st block. They're going to accept the Latin American 101st block because now everyone wants to work on the 103rd. There was no contention on who was first in the 102nd. And so it can happen that this can take a couple blocks to work out. But because every miner is incentivized to not only accept the block as quickly as possible, I want to convince all of you to work on the block I'm working on. So the whole ecosystem is incentivized to accept new blocks and keep moving on to the next one.
But to the previous question, how are transactions verified and double spends prevented?
Right, so there are two ways. So one is that, well, there are three ways. In any given transaction, the credits and balances have to equal. So there can't be a double spend in there. When you add it up into a block, this block is not valid if there are any double spends. So you can, again, just do the math and say, is it a valid block? Oh, no, there are some double spends in there. So then when you're in this consensus architecture, you could have a double spend. I could simultaneously buy some coffee in Latin America and buy a book in China, and those two 101st blocks are double spend. That could exist on the planet. But sooner or later, a consensus is going to emerge, and one of those double spends will not be accepted. So because the blockchain is one linear set of blocks, each of which have no double spends, then once we have the consensus over which is the legitimate set of blocks, we have no double spends in the system.
The fork will eventually work.
The fork is the chain is a hydra. It's actually, the better way to think of it is if you have a transaction, say the largest transaction I know of on the blockchain was $150 million. But that was from a book that was a couple years ago, so it could easily have been more by now. If the block that says you got $150 million from someone is the most recent block, well, you should wait a little bit. And so there is a bit of wisdom that says you should wait an hour, which is 6 blocks. But if it's $150 million, I'm going to wait a lot more than that. I'm going to wait a couple days. And you know what? Banks make me wait even longer than that. So this is all reasonable in terms of making sure that the money's really there. But if I've had 7 days of blocks playing this consensus game, every 10 minutes, it's going to be really stable. It's going to be like 6 sigma stable. It would be incredibly hard for someone to falsify the entire blockchain and reverse that transaction, so I don't get that $150 million. They would have to computationally falsify all the nonces and all the hashes for all those 7 days, which is just computationally infeasible. In fact, this is one of Satoshi's primary security arguments. If you could gather enough the computational resources to execute that kind of 51% hack, you would make more money mining Bitcoins. So just mine Bitcoins. Join the party, come on in, play poker, let's go. And this is the primary security architecture. So when you're thinking about whether or not different blockchains are still stable, and this is why proof of stake, a lot of cryptographers don't like it because it doesn't have that architecture.
Are there uncles in Bitcoin?
Are there what?
Uncles in Bitcoin, where like, if you reach consensus at the same exact time, do you get a lesser reward? Like
No, it's all or nothing.
all or nothing? Okay.
Yeah.
It sounds to me like miners here, like sort of miners in the real world, that they're doing an incredible amount of labor, and what they're mining what point would it not be worth the miner to do the mining? Because
Right, so when does Satoshi's argument about security fall down? I'm actually really curious about that. I don't have a good answer. But right now, so what was Bitcoin at? Let's call it 4K. So Bitcoin's at 4K. That means every 10 minutes, $50,000 is being created. 12.5 new Bitcoins are being minted. So that's roughly $50,000 every 10 minutes. Plus the transaction fees, which right now a transaction is about $1 last time I checked. If you have 4,000, that's another $4,000. So you're looking at, call it $55,000 every 10 minutes. So I have to win. So it's not like I can set up my farm and just farm it, right? It's not carrots. They don't grow no matter what. But statistically, if I can get out there and capture 1% of the market share in hash, then statistically I'm going to get 1% of the Bitcoins. So in that case, if I'm getting 1%, then every 10 minutes I'm getting $500 in value. So how much is that worth you to spend in buying computers? And this is why John McAfee and Putin and probably Kim Jong-un are building farms so that they can get their hands on currency. But the numbers add, I mean, you know, I don't know if any one farm has 1%. I don't know what the distribution looks like. But it's not inconceivable that someone has 1% of the global hashing power. They would have to get 51% to execute. So at 1%, I can make $500 every day. What was the number? $500 every 10 minutes. That's crazy. I'm working on that for my consulting rate.
Is there something in the infrastructure that like can show a graph of how that's distributed amongst miners?
No, because there's no innate identity. So I could be winning every Bitcoin today and use a different account every time. And you could do network analysis and try and see where those are coming from. You could watch the network traffic, and you can know they're coming from China if you're sitting on the major interchanges. But there is no innate way to know that those are one guy or that they're colluding or anything like that.
There's no block explorer with like an address to the mining, monsters essentially, and the big players.
Well, from the U.S., all you're going to get is some IP that goes through a NAT into China.
There's no public address, like saying like public address one this block.
Well, the address is just a public key. It's a hash of the public key. So I can randomly make that up every time. I can, for every Bitcoin I win, use a different destination account. So you can correlate by looking at the network, and you can know that I'm in North America. That wouldn't be that hard to do. But getting more than that would be very hard. And you couldn't prove that I'm the same person. Could be just a bunch of Americans got lucky. Okay, so this is a consensus architecture, very simple, elegant algorithm. Eventually gets a majority. Okay. Already answered the question about this is how double spends go away, and that it can take some time. Okay, so what Bitcoin's really doing is a lot like Tom Sawyer and the white picket fence that he got his friends to pay him 10 cents to whitewash. create these economies that work are you have sinks and you have sources. So what we need to have a stable Bitcoin are places that spend them and places that buy them. What makes dollars stable is that you have to pay your taxes in dollars. And the government pays its contractors in dollars. And that the Saudis will only sell oil in dollars. So these sources and sinks are what stabilize a currency. If all of the manufacturers in America started only accepting Bitcoin, that price would stabilize real quick. But we don't have those sources and sinks yet.
And there's been talk before of other countries perhaps not recognizing the dollar as the main currency. So fiat doesn't have a real economic value. It's you people saying what the value is.
That's
Backed by gold. So I don't see a difference between a dollar and a Bitcoin myself.
That's right. Well, there are some interesting differences with dollars. You can't do fractional deposit lending with cryptocurrencies. But yeah, the last sovereign state to sell oil in something other than dollars no longer exists. It's a country called Iraq, and we didn't like Saddam Hussein selling oil in euros. Whether that was the reason, I don't know, but okay. So there's another weird trick. How are we doing on time? Okay. I guess I have lots of time. So when I went to go see the eclipse, I listened to some audiobooks. I listened to 3 books. One was awesome, one was good, and one was crap. The one that was awesome was just Nakamoto's emails, the non-technical ones that were talking about. So it was in his voice talking. That was great because I wasn't there. I wasn't in those lists, but it sort of connected me to what his conversation was about. The one that was good was written by a bunch of Wall Street Journal guys, and they unpacked what money is. Because frankly, most people don't understand money. And part of what's interesting about the dollar as a fiat currency doesn't have a real standard. The reason commodities became the foundation for currency is because they were easily countable. It was so much salt, so many ounces of gold. You could melt it down, you could reform it. It's still well-formed, so many ounces of gold. Other communities use coffee beans. It was because of the countability of the commodity that it was a viable medium for transactional exchange. Transactions by themselves create value. So I don't know if people have heard this in their microeconomics class, but if I have all the tea in all the world and you have all the water in the world, then you're not getting any tea and neither am I. I just have the leaves, right? But if we can exchange a cup of water for some tea leaves, we just created value. And so every voluntary transaction creates value. So currencies generate wealth in the world by enabling transactions. We can both have exactly the same amount of money, the same amount of physical goods before and after the transaction, but we are both happier. We are both better off. We're both wealthier. So Bitcoins go back to very clearly and exactly knowing exactly what the countability is in the system, right? It's very countable like beans or gold. It's just not tied to a commodity. And because I believe in the countability, I'm willing to have transactions. And if you're willing to take my Bitcoin for that pizza, we're both happy. Because maybe you'll turn around and take that Bitcoin to buy a song or whatever. So as long as there are people willing to transact, then the currency is valid. It does not have to be a traditional store of value where the thing itself has some market commoditization. Right? I think pennies have negative value. Right? Things like that. So money is a slippery and subtle thing. And I think literally the triple entry bookkeeping gives us a completely another different way to experiment with money. And I think it's pretty profound.
What was the bad thing that you read?
It was a book by Dan Tapscott. And actually it was the Tapscott brothers, I guess. And when I mentioned these 3 books, a guy I'm collaborating with was like, "Oh, was one of them the Tapscott stuff?" It was so bad. literally, I wrote an Amazon review, and I said, this thing's only good for knowing what the Kool-Aid is, because it was so overhyped. He would in one chapter be gushing about how Bitcoin and blockchain is so transparent, it's going to make everything amazing. And then in the next paragraph, talk about how it gives such anonymity, and that's where its power is. And you can't have transparency and anonymity in the same architecture. The guy really didn't understand what was going on. And I finally got why so many people at these conferences I go to, when I say things that I think really are technically sound, they're like, you're crazy. And it's because they're hearing these Kool-Aid hypes, which isn't quite what I said, but what I said was so close to the hype. And I'm like, oh, that's why people think that idea is crazy. So we're going to get to identity on the blockchain shortly. And that's one of those things where people are like, Joe, what are you smoking? OK, so I want to move through some of this quickly because hopefully we've taken some time and you guys got some idea about how the blockchain works. I mentioned it can be permissionless. You can put anything on that audit trail, which is great because you figured out a way to pay the world to audit your books. And we already talked about people are working on alternatives to proof of work. Thank you for that. So Ethereum is it's definitely the leading altcoin out there. It embeds in every block, every transaction actually, Turing-complete computations. I'm sorry, there's a language that's Turing-complete. And so the miners are not only finding the nonce, they're also running a bit of code. And depending on how complex the code is, the transaction fee is higher. And it's written in a language called Solidity. We've got a couple of cats around here, this guy and a few others, who are writing apps in Ethereum. And I'm not going to explain what this is because I don't have time, but it's pretty cool. All these miners are simultaneously running this code. And as long as the code doesn't have bugs, it'll all work great. and we'll get to that next. It's a little bit faster, 12 seconds a cycle instead of the 10 minutes of Bitcoin. But because there are so many more forks, soft forks, because it's only 12 seconds, so it's far more likely that our Latin American and our Chinese guys simultaneously say bingo, that it has approximately the same settling nature. You still want to wait about an hour to really know. There are some ways to accelerate that, but I don't want to get into that. But the most interesting thing going on here is with these, they're called smart contracts, the code that's written in Ethereum, you can create custom tokens. So you can embed in this code a way to have additional tokens that are not Ether, which is the currency in Ethereum. They're your own thing. So initial coin offerings are a thing. And they're really in a huge amount of flux right now. They're kind of like an IPO, but they're nearly unregulated. And they don't necessarily give you equity in whoever was selling the ICO. And I'm going to give you an example of what I think is a very legitimate ICO, but there are also a lot of crap ones out there. They're anchored to Ethereum. I mentioned they're like IPO. I think there's over $1 billion in the last 12 months. When I gave this talk a month and a half ago, Filecoin hadn't launched, and that number was 300 to 700 or something. Filecoin popped $200 million. Going to talk about that shortly. And VCs see this as an opportunity to be liquid earlier. So VCs can take the company, and this is what they did with Filecoin. Union Square Ventures and other A-list VCs were involved. They took Filecoin to an ICO, and now they're in the market. Now they have value that they can exchange in the marketplace without a formal IPO. So it's kind of attractive to VCs. And this will matter later. These VCs did everything they could to make it legal with regard to the SEC. OK, so the most famous ICO was something called the DAO, the Distributed Autonomous Organization. It was really cool. It was basically a virtual venture fund. If you bought into it, you would get the right to vote on proposals that anyone could pitch. And if you got enough people to support your proposal, the smart contract would pay you the money as soon as you got those votes from enough token holders. So it was thought of as a notion of radical self-governance. You didn't have a board of human beings. You didn't have gatekeeper CEOs. Any proposal that was meritorious could be approved. Problem is there was a bug. And actually, I could have mentioned this before. I think a third of the Ethereum market capitalization was raised in the DAO. So it was a huge proportion of the Ethereum market was wrapped up into this really exciting idea of the DAO. So there was a bug in the smart contract. Someone exploited the bug, pulled out $30 million. Other folks noticed that this was happening, went all Robin Hood on their ass, and went and stole the rest of the money and kept it in escrow and eventually gave it back. So the entire DAO itself was bankrupt because all the money was stolen from it through this hack. Half of it from white hats and a third of it from black hats. They proposed something called the soft fork, but they didn't do it to fix it. They eventually did a hard fork. And the people behind Ethereum, the miners that were mining Ethereum, the developers, the people who were really invested all said, this is untenable. We're rolling back the chain. So they built a technological architecture to guarantee that these smart contracts are going to happen. And then the social contract said, oh no, that's too fucked up to allow. We're going to reverse it. So, you know, it's like Darth Vader saying, what's the line about your faith in these technological marvels? The technology is not the final arbiter, even as much as you try to make it that way. So this is part of what happened. The old chain continues, Ethereum Classic. So the Ethereum guys who said we're gonna go back to this blockchain, they didn't have any ability to invalidate the other chain. It exists in the world. All they could do was fork it and say, okay, all the good people are going to come with us. Well, Ethereum Classic is the old one, and it's still out there. It's still currency. It's still in use. It still buys stuff. It still sells stuff. So it's kind of wacky how all this works. You can walk away, and that's really all you can do. You can't stop other people from doing their stupid stuff, which, as a libertarian, I think that's pretty cool. A month or two ago, the SEC said, by the way, those DAO tokens, yeah, those were securities. And nothing we've seen explains why they would be exempt from regulation and registration, which is basically giving everyone involved in the DAO notice that someone's going to be fined or even go to jail over that. So the SEC is finally weighing in and saying, these are securities, and they need to be regulated because people get ripped off. And frankly, after this hack and all this fucking drama, yeah, you kind of want the sheriff to come in and do something.
But also defend portable Ethereum. Currently, that was like an old version of Ethereum, and there's still like 2 more iterations coming out, Metropolis and eventually Serenity. So hopefully by the time Serenity comes around, they won't be able to have that say going back and forth. But until Serenity does come out, they are allowed to come in and say, hey, that was messed up. We're going to kill this chain. So all hands are off after Serenity, essentially. After they completely fix Solidity and they completely patch out all the theoretical bugs for Ethereum.
So like Bitcoin improvement protocols, if you get enough of the population to agree to change it, it will be changed, regardless of what technology is there to prevent that.
Yeah, for now.
Well, no, always. They could always just do a hard fork. So one of the hard forks on here I didn't mention, right, Bcash. They didn't like the 1 megabyte limit and maybe a couple other things, like the responsiveness to difficulty levels. And what they did is they said, everyone who on this date has a Bitcoin now has a Bcash coin. They just gave them all money. So if you had some Bitcoin, you suddenly had this other all currency that you could spend. Now, people basically just dumped it on the markets, and the value is 1/10 of what Bitcoin is, but it's not 0. So that could still happen. Someone could say, I love Ethereum. If you have Ethereum, I'm going to give you 1 Methereum. And I'm going to create the Methereum network. And since mine's so much better, everyone's going to switch to mine.
I think that's why they're changing proof of stake now, though, is that they want to completely destroy the possibility of having a hard fork when Metropolis comes out.
It's open source.
I don't think anyone's going to adopt it because they're updating with Ride and all that stuff too.
Now, I think, there's a great book by Cory Doctorow called Walk Away, and it's about this morality of really your only option is to walk away. So I can choose to continue talking to you, or I can walk away. I do not have a moral choice to punch you or to kill you or to make you stop talking. And that's sort of how these forks are happening. They don't have the technical capability to shut down the other guys, but they can go start their own party. Oh, you're a jerk. We're going to go party over here. We're going to the next bar.
I was wondering how fast or how quickly is the SEC regulating these ICOs? How much attention
I think there's a small group within the SEC that is very actively pursuing this. I know they've stopped the trading of one company on the NASDAQ for their activities on the ICOs. And they put out this press release that they were looking to do some sort of enforcement action basically in the DAO. But that's all I've seen so far. I think they have questions of policy that they need to settle internally, which will affect who they choose to go after. So they want to find the guys who are the most egregious targets to have the biggest impact to stop that kind of behavior. So I don't have a better answer than that.
Wasn't the ICO Filecoin for accredited investors only for this?
Ding, 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 ding. Yes. So Filecoin, which it actually, I went too far. They did a $200 million ICO about a month ago. It was 2 days after the last time, the other version of this presentation I gave. So they were backed by Union Square Ventures and others, and they did in fact do everything they could to make sure they were compliant with SEC regulations. So they were using this architecture in an innovative way, and I think the SEC is going to want to say, you guys tried to play it right. We're not going to put you in jail, but we may provide some guidance because you didn't quite do it the way we want to do it. I think the DAO guys are going to burn because they think that between the hack and the theft, they're like, this is not okay. There needs to be more regulation there. And that's why who knows who they're going after or how they're doing it. But yeah, Filecoin did everything they could to be up and up. The other nice thing about Filecoin, so the idea with Filecoin is they built a technology before ICOs were even a thing called the interplanetary file system. So there's a distributed file system. You put data in it, and it's sharded and hashed, and it's around the internet. And no one else can access it but you. It's a fully distributed data store. And their Filecoin marketplace is going to let you pay for storage in the IPFS and also sell your own storage to earn Filecoin. So for example, you could sell space on your hard drive to get backup space that's off-site and end up 0-0, all using Filecoin. So this is, to me, this is a brilliant use of a token that represents real value in terms of storage. And they're just facilitating transactions and creating value for all these underutilized resources. I would use this today. Now, they're not the only one. There are other people doing similar things. Storage had a crazy ICO that all broke a bunch of stuff that I'm not going to get into. But this was a legitimate ICO. And people are going to be creating ICOs like this for all sorts of things. I think people are going to be using it for clean electricity. People are going to use it for people are using it for bandwidth, for Wi-Fi. So if I can put up a Wi-Fi in my neighborhood, if other people are using it, I get coins for it. And when I travel to some other neighborhood, I can use those coins. So this is unique value that's being created by ICOs. These are not scams. These are legitimate new tokens that are enabling new types of transactions. So that's all pretty cool, in my opinion. And here's their page. There was a video. It was cool. It was sexy. They raised $200 million in less than 24 hours. Of course, it was, an overnight success that they spent years getting to. Okay. Yep.
So like something like Filecoin, it enables this specific use case, I guess, and storing stuff. And is Ethereum I guess what does Ethereum enable? Does it just enable you to build apps on a blockchain network, or
That's right. So Ethereum lets you encode. It lets you write code that's embedded in your transactions. And so these smart contracts are that code that gets embedded. And do you remember the number BIP? It's not. I don't think it's a BIP on Ethereum, but it's number 23 or whatever that lets you do an ICO. There was a specific improvement. ERC20. So that's right. ERC20 is like the Bitcoin Improvement Protocol, but it's the Ethereum whatever. That standardizes how you make ICOs. And it basically makes it very easy for you to create your own coin, your own token that's anchored on the Ethereum blockchain. And you can only exchange those tokens for those tokens within that network, just like Bitcoin can only exchange for Bitcoin. Now, you can give me Bitcoin and I can give you money. That's exogenous. So it's the smart contracts that enable the coin creation.
So are all of these altcoins on Ethereum? Like built on top of Ethereum?
All the ICOs that I know of are. Not all the altcoins. So Dogecoin, Litecoin, Sovereign, which we're going to get to here, those guys are not on Bitcoin.
They're not on Ethereum?
Right, sorry. They're not on Ethereum. But if it's an ICO, 10 to 1, probably 100 to 1, it's on Ethereum. So, and when you're done, you can finish, but there are two guys behind you, and I just want, you're going to be next in the far back, and then you're next after that, yeah. Did you have more? Yeah.
Oh, yeah, I guess.
Okay, so we're good. In the back then.
Yeah, so Filecoin raised $200 million at a $2 billion valuation. So do you think that's a sign of a bubble when a company can raise a $2 billion valuation with no real product?
So I don't believe that Filecoins represented equity ownership.
They sold 10% of their coins.
Right, but that is not equity and ownership in the company.
They weren't selling the company, they were selling.
That's right. So I think it's a false equivalency that I don't know what the right equivalency is to have a fair answer to your question. Right? So
2 billion tokens, and they sold 200 million of them, or $200 million. So the value of the network is.
right, but if you were telling me, is it appropriate for this startup to have a $2 billion valuation and to raise $200 million? I have a lot of context to be able to answer that question. If you're talking about someone who's creating an entirely new token marketplace, I don't have a context to answer your question fairly, is what I'm saying. Oh, I think it's awesome. I wanted in on it, but I'm not an accredited investor because I didn't make enough money last year. But yeah, no, I actually think I would have liked to have gotten in on that because I think they're creating real value. A bunch of other ICOs out there, I don't have that. I think they're just a unicorn. I think they're very unique. They're nailing it. They're doing it right. And, there are unicorn startups. And they're not all a waste of money. Some of them are simply innovative and ahead of the curve. And I think they fit in that category. And right here.
Is the end goal an ICO to become a cryptocurrency?
An ICO creates a cryptocurrency. So typically there's a threshold, kind of like a Kickstarter. So you have to get so much capitalization into the ICO to trigger it. But once that gets in there, the cryptocurrency exists. It's an initial coin offering in the new currency. So when Filecoin hit its numbers, there are now Filecoins. Now, there isn't a network using it yet because they're doing the integration to get it connected to IPFS, and that'll take some time. But the currency exists. People now own Filecoins.
No, but I thought the only cryptocurrencies were Bitcoin, Ethereum, and the other smaller ones.
Nope.
So even these new tokens are considered cryptocurrencies?
Yes. So the ICO base, the Ethereum base, the underlying architecture for consensus and block building, I believe is all Ethereum. But there are different coins that are using that architecture. And then there are a bunch of altcoins like Dogecoin, Litecoin. They're their own thing. And they're not on Bitcoin. They're not on Ethereum. They're their own blockchain and their own cryptocurrency. Okay. Okay. I'm going to try and move forward. I feel like we're going to be here till midnight. Okay, so self-sovereign identity. I'm going to go through this faster than I'd like to. This is near and dear to my heart. I already touched on a little bit about how the blockchain lets you just create an identifier without someone having to give it to you. There's no external trusted authority that manages the identifiers in these accounts. So the idea is let's do that to keep track of identity more generally. The current work that's going on, there's a group called Sovereign that's created their own blockchain. The company, this is a nonprofit. This is a for-profit company in that workspace. There's also work going on at the W3C. This is the World Wide Web Consortium. These are the guys who manage HTML. So they're Tim Berners-Lee standards organization. And the work there are things called verifiable claims and the credential CG. And an effort called DIDs, decentralized identifiers. And what it did is it just takes, you take this random identifier, like a blockchain address, and you can attach a mechanism so I can prove that I can control it. And I can cycle or rotate the keys that do it. I can even provide mechanisms for key recovery if I lose my key. All of these using basically smart contracts. So some of the biggest risks about losing control over your identifiers you can implement in smart contracts. And this sort of gives us a very powerful way to do identifiers that are completely independent of any given authority. So you won't have to buy an SSL cert from Network Solutions anymore, because I hate that crap. So the second part of this that is kind of, literally changed my career when I got involved in this space. 2 years ago, the UN shepherded a treaty about sustainable development goals. One of the goals, goal 16.9, Sustainable Development Goal 16.9, is to create a legal identity for everyone on the planet by 2030, including birth registration. Turns out there are about 1.1 billion people without a legal identity on the planet. Something like 11 to 19 million in the United States, which at first sounded incredulous, but the bulk of that is in illegal immigrants. When you don't have a legal identity, you don't have recourse to justice, you don't have access to social services, you don't have access to health care, you don't call the cops, you're a non-citizen. So the UN wants to fix that. And there was this workshop, we've done 2 of these now, I wasn't running them, but I attended them, basically to try and figure out how to use the blockchain to cost effectively provide legal identity for these under-identified individuals around the world. Not all of them are refugees. A lot of it gets wrapped up in a refugee conversation because that's, you know, in sort of a distorted way, it's a sexy thing to talk about, the refugee crisis. But a lot of them are illegal immigrant workers. In fact, that's a much larger population. And some of them simply live in a part of the world where there isn't the civic infrastructure to give them a birth certificate at birth because it's just too poor. So one example of this, I'm actually hoping to get involved in this project, but we'll see if that happens. There's a border region between Myanmar and Thailand where there are 9 or 10 tribal regions. There are 9 or 10 camps where these tribal peoples live who basically refuse to integrate in either Myanmar or Thailand. They're like, screw you guys, we're our own people. It's a rugged area, it's very hard to actually subjugate them through traditional means. So they've lived in this interzone between the 2 sovereign nations. This organization called iRespond has done some really great work using biometrics to bootstrap medical records in third world countries so that when the next time the Médecins Sans Frontières doctor shows up, he can use the biometrics to pull up the records from the last time the last Médecins Sans Frontières guy showed up. So he's now working on providing a way to create self-sovereign identities for these tribal peoples, and he's gotten the tribal leaders to buy off. They believe him because he was able to legitimately tell them, this is not something given to you by the government. This is yours. You own it and you control it. And at the same time, he's gotten the governments to use it, to issue work permits, to deal with taxes, to deal with social services. So he's basically bootstrapping legitimization of what in this part of the world are essentially a bunch of legal immigrants crossing the border and working illegally. So there's a whole gray and black market that he's going to help bootstrap out with self-sovereign identities so that these people can start to take control of their lives and the sovereign states can start integrating them into the above-board economy. So that's self-sovereign identity. There are a bunch of other applications. This barely touches on it. People are doing chain of custody for medical devices, for food. Boeing and Accenture are using it for airplane parts, which all have very sophisticated mean time before failure kind of things, and how has it recently been maintained, and who has a record of that. Delaware now lets you deal with corporate governance with blockchain technology. China is going to let people pay taxes. It's probably going to be the great Bitcoin of China, given what they're doing right now. People are working on side chains where you can get things like smart contracts, but attached to Bitcoin. So you can have faster transaction lightning networks, and you can do smart contracts, etc. In education, people want to put credentials on the blockchain so that you have a very provable record that you have your bachelor's degree or you've completed, what is this place called? That you've completed, you're a hackreactor graduate, or that you've passed some other program or accreditation. In banking, all the big banks are trying to figure out what to do. The credit unions have a credit union association. They are trialing services to figure out how to use the blockchain to do things. One of the more interesting ones that I like to talk about is they're looking at reinventing credit default swaps. So credit default swaps were the bane of the subprime mortgage collapse. And one of the problems, there were really two problems. One is the mortgages themselves were crap. They shouldn't have been sold. They were sold to people who couldn't pay them. And then they got rated inappropriately by the agencies. If you've seen The Big Short, kind of unpacks all that. But on the other side, we didn't know who was exposed to all this liability. Nobody knew that it was AIG and Lehman Brothers that was going to fall apart. But if you have it on a blockchain, you know both who owns it and what the underlying quality of that asset is. So you could know that Lehman Brothers and AIG are in fault at risk right now. And you could respond to that before it collapsed. So that's all kind of very cool. And let's be clear, that is going to be a permission blockchain. And only the banks that are part of the cohort are going to see what those transactions are. You and me aren't going to know that Lehman Brothers is at risk. But Morgan Stanley and Goldman Sachs and all those guys will. And then there's a whole bunch of gambling stuff. We talked about some of those. It's not that interesting, but it is happening. Not interesting to me personally. Real quickly, this is Apache and Linux versus Microsoft. So these are basically in the enterprise space. IBM started an initiative called Hyperledger. Indy came from Sovereign. They provide an identity layer. It's private. It's for permission ledgers. It's basically a toolkit for enterprise to build, sort of the version of intranets for the blockchain. And it's now, from a software standpoint, managed by the Linux Foundation. So deep, deep credibility here. Microsoft has its own form of credibility. Blockchain as a service, which is a horrible brand. But you can spin it up on Azure instantly. It is Ethereum based, so it's not entirely their own thing. So they're integrated. In fact, Solidity is now part of Visual Studio. Are you using it that way?
Yes.
Yeah. So that's pretty awesome. I mean, one of the things Microsoft does great is they have great developer tools. So if you want to write Ethereum apps, boom, go use this tool, and you can test them on Azure, and now you're in the Microsoft family. And there are a lot of businesses that are very happy being Microsoft houses. They create a lot of value, and IT departments are happy, blah, blah, blah. There are a bunch of us developers who are like, fuck you. But, all right, this is being recorded. But this is an old story, right? Linux versus Windows, and this is just reiterated here. Accenture actually deployed a program for the UN using this platform. Okay. All right. We're on to part 3. So this is great. I'm glad how are we doing on time?
Great. Maybe about 30 more minutes.
Yeah, I can frame this in that. Yeah. Okay. So there are a lot of challenges. I may have touched on the first one earlier. I don't know how many of you were here. The real Bitcoin mining today is being done on custom developed integrated circuits called ASICs. You can buy an ASIC rig for about $2,000. I don't know what the kilowatt per hash is. but that's really the metric that you'd want to care about because it's really about the currency, the translation of electricity into Bitcoin hashes. So you can imagine you're not going to be able to compete mining using a JavaScript engine. So for those of you who thought maybe that's what I was going to show you how to do, that's not what we're going to do. And in Ethereum, Solidity was really written to run on GPUs. So again, JavaScript doesn't really help you there. But you can, if you have a decent GPU, be in that space. You can mine Ethereum today, and I think you have a chance. I don't know what the numbers look like. I don't know if it pays for your electricity. But it's much better than Bitcoin.
$3 a day average.
Yes. So, and the other thing is, if you turn these guys on, these miners on your desktop, because you're like, oh, my computer's on anyway. Oh, no. It's going to take over your machine. Your mouse will slow down. I mean, so this is not really the game that I would recommend most of you get into. But there is some interesting stuff we can do. Wallets is one area. One of the problems with wallets is if you lose that DAT, you lose the money forever. There are definitely hundreds of millions of dollars that are gone now because wallets were lost. And since there's a fixed number of Bitcoins, it's actually deflating because there are humans involved, and over time, wallets will lose Bitcoins. So we're just going down until there's none left. And the security model in the browser really doesn't want you to interact with the file system in any reasonable way. I had a company that was doing that through, it's just, you're fighting them the whole way. It's a pain in the butt. But there are some things we can do that are wallet related. I'm going to show one. It's one of my favorite apps. The JavaScript engines also simply just aren't as mature as the Bitcoin Core, which is the main C++ based application that's running all the non-ASIC based interactions. So when you're talking about transactions where in minutes you can lose hundreds of thousands of dollars, you really want to have the most mature stuff. And I don't think that's the JavaScript community at this point. So on the server side, you do have some options. Two of them are crossed out down here. But one of them is a wrapper around Bitcoin Core. That's called Bitcoin Core. And that's what I'm going to demo. Just real quickly, I'm going to show you. It's really easy to use. And you basically, within a Node app, can query Bitcoin Core running on your desktop. So I've got Bitcoin running on there. It's connected to the network. I'm going to go get some money. And you guys will see my Bitcoin balance go up. But this is a wrapper, right, around the C++ app. There are a couple of native implementations. Two of them, for reasons of stability and maturity, I've crossed out. But these two, I think, are solid. So Bitcoin.js looks like a great library for interactions, for things that you want to do that are not directly on the chain. So if you want to construct a transaction, you want to construct that little debit and credit thing in the transaction of the signature, you can use that library to do that. It won't get it onto the chain, but it will create the raw transaction that you could then send to someone who would put it on the chain. Bitcore is actually a full stack, full node, pure JavaScript implementation of the Bitcoin protocol. I really wanted to demo that, but it doesn't support Windows. And although I'm a Linux guy, for my clients, that's Windows. And I wanted something that could do both. So that's why we're not demoing that. But it looks pretty solid. It looks pretty interesting. It looks like it has a lot of use. It has both client and server. And it is the only full node that I know of in JavaScript.
How big is it?
Super big. No, I have no idea. NPM install. It just worked. I didn't do a df or du afterwards, right? Bcoin. So both of these are actually recommended in one of the books that I like, Mastering Bitcoin, the O'Reilly book. But these guys, they looked really good. But then they had a link that said, click here to run a full node in the browser. And I was like, you guys are cute. No. Maybe it was an April Fool's joke that's still there, but then you click on the link, there's another page that says this is going to consume CPU and bandwidth, and are you sure you want to do it? And there's another link. That link basically 404's out. So I'm like, come on. If you guys are being legitimately maintained, you aren't going to have a broken link like that. So they don't pass my test. CryptoCoin actually says in the GitHub, we're not sure if we're going to maintain this because some of the most interesting work is going on in other modules, and it hasn't had a commit in 3 years. So they might work for you, but I would go with something that has active support. Okay, so I'm going to show you this offline wallet management. I think it's super cool. So the problem, I would like to turn off my Wi-Fi, but I understand that's a problem. But the idea is for what's called cold storage, you want something that's completely disconnected from the network. So this is a USB stick running some HTML JavaScript. It's a little web app, single-page web app from bitaddress.org. And I could be totally offline, and I'm going to do this. I'll leave it on. You guys just believe me that it'll work. Come on, open the folder. So this guy is going to let me generate public and private keys, and then I can print them out. And so the first thing it's going to do is I need to generate a bunch of entropy by moving my mouse. And it's just giving me some visual feedback, and then you can see it's generating this randomness here. And that's so that your randomness generator truly, truly is randomness. It's not whatever the rand generator is in this language on this CPU. Okay, and you only need to do this once every time you refresh the page, because once you have a seed, it's good from there. And then, so here's a single wallet with a QR code. So I can print this out, again, with a printer that's totally not connected to the internet. And I can store this in a file in my fireproof safe. And I can use the QR code or the text numbers here to receive money. That's the public key. And I can use this secret to spend the money. And it's all completely offline. And this is a brilliant use of JavaScript. So there are applications like this where you can do a lot of interesting things. One of the things I'd like to see is a completely user-centric, not in Coinbase, portfolio viewer. So I can go to Coinbase and I can see what my current ownership that Coinbase knows about, what it is in their current marketplace. But I'd like to have a USB that simply knows what my accounts are, gets that from the network, and shows it locally. That would be another great little JavaScript app that you could write. And I had fantasies about writing it for this, but I didn't get to it. So these guys, you can do one wallet. You can create a bunch of them. You can turn off the pretty little graphics. Whatever. It's just a nice little... that's all. So you can check this out, bitaddress.org. This is a cool little JavaScript app. And all of that's completely off the network, so I know that nobody else has seen it. Nobody else has a private key. Nobody's going to be able to spend this money except for that guy who just took a photo. Okay, so that's that. And then the other thing I'd recommend, so you can use Ajax to talk to various third-party services if you want to trust them. So Coinbase has an SDK, BlockCypher and Blocker.io here. Both have tools where you can get information and post transactions. And the best practice there, if you're going to do that in the browser, is to use multiple different vendors to make sure that your transaction really got posted. So if you post it with one, verify it with a different one. Because Coinbase could say, oh yeah, we posted it. And they can be totally lying to you. And they're probably not. I mean, they seem to be a legitimate company with legitimate practices. But they could be hacked, or there are all sorts of ways it could go wrong. And the whole point of Bitcoin is to get rid of that dependence on a trusted authority. So check your work. Here are a bunch of examples, again, if you download the PowerPoint. These are working code examples where they're reading the blockchain via BlockCypher, and here they're signing a transaction and sending it to Blocker.io. So these are working examples. We're not going to dive into it. I think if you're making a serious Bitcoin-based app, you're going to write a web app. You're going to use some JavaScript there. You might use some of these client-side tools, and then you're going to write a server app in Node. And whether you do full stack with the Bitcore or use Bitcoin Core and you wrap it around the Bitcoin D, I think that's probably the best architecture for you.
Doesn't that ask your client to trust you as the central authority then?
Yep. Yeah, that's part of the problem. I mean, I have coins at Coinbase, and I don't have a lot because I just sort of want to see, but they could be hacked, and I'm like, they want my money. But yeah, that's part of the problem. So unfortunately, most, if not all, of the peer-to-peer network and the actual synchronization between the miners and the posted transactions is JSON RPC, and you can't do that from within the browser. So you can't directly communicate with the blockchain within the security model of the browser. Somebody loves me. Okay, so let's do Bitcoin Core. This is going to be really fast because there's not a lot in here, but it is going to be live. And I say fast because we're going to do a thing, and then we're going to have 10 minutes to talk, and then the transaction will get confirmed because it takes a while, right? Okay, so Bitcoin Core, pretty easy. You need to download the Bitcoin D and get that running. And I really wish I could have had all of you doing this, right? That we could have had a portion of this where I was like, okay, bring out your laptop. But it takes 2 hours just to download the testnet on a desktop with a good fast connection. If I had suggested all of you do this, we would have brought the network to its knees. And certainly we wouldn't have been sending out any video to anyone. So give it a couple hours. If you were actually using mainnet, which is where the real Bitcoin is, it's a 24-hour download. It's over 100 gigabytes. But start with testnet. And with Bitcoin D, it's easy. You just --testnet as the parameter. So I started in a Linux in the cloud. That machine literally got pawned within 24 hours. Someone else saw that I was doing Bitcoin transactions and took over the server. Fortunately, all I was doing was this testnet, so it didn't really matter. But I moved the wallet, and it's pretty easy to just rescan if you pass in the rescan. So you download that, let it run. Set up Node. Hopefully, folks are already familiar with Node. If you are, this is all pretty right. You use a fairly recent version of Node. Bitcoin Core needs 4.8. I made a directory. I cd'd into it, npm init, and I npm installed. Whoops, I didn't mean to go there. Really straightforward stuff if you're familiar with Node. It's not going. Okay. Oh, because I took it out. Whoop. Okay, so none of this so far has been anything other than what you do with a normal npm module. And that's the magic. Other than running that Bitcoin D, it's like any other npm init. You install it, any other npm module, and then we're going to use these commands to go do some cool stuff. So let's go do that. So we're going to run node. We're going to create this const client equals require. Whoop. By the way, holler if I have typos, because that'll speed things up. Right, pretty standard. Oh, what did I do? Damn it. It should be an equal. Yeah. Okay, and then I'm going to create an actual client from that. New client. Test. It's really hard to type when people are watching you. I'm sure you've all had that experience. The boss comes by and you're suddenly Butterfingers. So I really have a secure username and password, as you can tell. And so we're just going to do a client.getInfo, and they have both a promise and a callback. Thank you. That's what I get for trying to explain it as I'm doing it. So I'm using the promise aspect of this particular call with some fancy ECMA. Thanks, yeah. Yeah, well, and I've been working with embedded systems, so I don't even get to use this crazy ECMAScript 6 stuff. So this is fancy, these arrow functions. Okay, is that right? Yeah, okay, so we just did a quick query, not a lot of crazy interesting stuff. You know, here's how I'm connected, the ports, blah, blah, blah. Let's get the balance. And then we are going to go add more to that balance. Oh, air comma balance. Okay. Yeah. So I've got 2.7 and change Bitcoins in the fake test net. So this is not, you know, whatever, $8,000, $9,000. But what we're going to do is we're going to go create some more. So because it's a test net, I might have one of those open, but I'm just going to copy it. There are several what are called faucets out there. And you can cruise to these faucets and give them an address. And they will give you money. Okay, I forgot that I needed to get an address. So that's client. So when you call client.getNewAddress, this is creating an address, a public and a private key, and storing it in your Bitcoin D wallet. So I'm not maintaining that in Node. Bitcoin D is keeping track of it in its wallet. So even when I exit here from this interactive Node instance, I'm not going to lose that wallet data. So that's useful. Whoop. Thank you. That. I did, yeah. Thank you. No, did I screw it up? All right, where's the comma? Come on, it's right there. Okay, so we're going to go put this address in this faucet. And we're going to say, give me some money. What? I didn't like my address. Oh, yep. Totally legit. It's going to make me do some things. There's a road, there's a road. Is there more roads? That's a road.
Right-hand corner.
Yeah, it's got a little patch of road. Is that a road? You know, it's a reverse Turing test is what it is. Is that a road?
It's like, is it near a road?
Yeah.
I think you can verify that. You're good.
Hey, we're dealing with cryptocurrency here, man. This is sophisticated stuff. Bottom, this one? There's a car? They really want to make sure I'm not a robot so I can get my fake coins. Okay, and look, it already came in, so we didn't have to wait very long. And then I'm just going to go up and get my balance. Okay, so the balance isn't there. So Bitcoin D saw my transaction from my wallet in the mempool. So the mempool is where all the transactions get posted. Now, the miners that are mining the testnet, basically because they're good guys, because they don't make any money off it, now have that in their set of possible transactions. Someone's going to pick it up and they're going to put it in a blockchain, and when it gets confirmed, I think just once, then my Bitcoin D will say, hey, you've got some money in there. I wonder if I'll get a little pop-up. Okay, and that's, I've got one or two more things, but that's basically a wrap. And we can go to any questions while that propagates through. There's a great walkthrough that a colleague of mine did. Again, click on the link in the PowerPoint. That's Bitcoin from the command line. So the first thing I did was I walked through this. And as long as you're familiar with Bash, he's working in Linode. So if you know that, that's an advantage. But it basically taught me all the underlying sort of hard stuff so that when I learned the JavaScript, I could say, oh, this is what's going on under the hood. So that's a resource for you. And then here are some of the other links that I've had elsewhere in the presentation. And here are the two. This presentation is available both as a PowerPoint and or as a PDF if you want to write that down and download it. It's just at my site, legendary requirements, LegRec, presentations, Pres, Bitcoin JS, LA, PDF. Yeah. And so that's it. We're going to hopefully see this transaction come up. And if you guys have any more questions, we had a pretty good rambling conversation around Bitcoin and blockchains and all of that.
Somebody somewhere have the whole blockchain going back to 2009, and
I do.
It gets bigger.
It gets bigger.
But especially if a whole bunch more people jump onto this, it probably gets really big.
God bless Moore's law.
Yeah.
Data's cheap, bandwidth is cheaper. So it's going to keep growing. It's part of the debate about whether or not we allow more transactions per block. So I think one of the Bcash now supports 8 megabyte blocks instead of 1 megabyte. There are proposals to just double the 1 megabyte to 2 megabyte. A lot of the people who are opposed to that are like, you know, you're just kicking the can down the road. A factor of 2 improvement isn't going to change anything. It's just going to keep growing. It's just going to keep getting bigger and bigger. Hey, a terabyte hard drive is what? A couple $100? Don't sweat it. I mean, that's literally how people are addressing that resource constraint. Is it this space keeps getting cheaper, so don't worry too much.
Does it divide up each block like its own file? Is there some way to manage that?
Well, you download them by block. You can see as you're doing the download, it'll tell you how far you're in, how many blocks you have. I don't know what the internal structure looks like. I'm not that deep of a developer, unfortunately. So.
Where's all the ledger information stored?
So it's in a file. I have the entire testnet blockchain on there. And if you pull up a full node, basically in the background here, there's a peer-to-peer network, not unlike BitTorrent. And so it uses an IRC channel for the primary discovery. And so it does a bit on the IRC, and then it finds seeds, and then it will go out and do the peer-to-peer file sharing. And it uses that to manage the mempool and to manage the to download the full blockchain itself. So, yeah, okay. Let me see if it showed up. See if I'm any richer. No, it's still taking some time. So, yeah,
When you make a transaction and you click the hash to see where it's at on the blockchain, you're directed to a website. So, for example, in Coinbase, they have, I forget what domain they have that checks the block in it. And you can see where your transaction is at in confirmations. There's lots of other different domains that do sources to see if you're, blocks, these different sources you're talking about. My question is, where is the core, like where is that data being fed from? How are so many different people, I guess, able to come up with these domains where they're getting fed that information?
So each of these guys are using one of two data sources. No, so the peer-to-peer network I mentioned that's in the background, it's sharing blocks when they're finished, so that's how you can get the whole blockchain. And this service, Block Cipher, is checking its record of the blockchain that I could download through that peer-to-peer network because I'm running a full node to see if there are any transactions with that address. There aren't any, so it comes back negative. But it also checked the meme pool, or the mempool, which is what miners pull transaction from to make the coins. And that's how they know it's 1.1 Bitcoin.
So that was my the next question I was thinking is like, where does the miners come in with that? Come into play with that process? So they're pulling the same information.
Right. Block Cipher is pulling the same public ledger and public meme pool data that the miners are. So it's all public. It's all out there. It's not like they go to a specific website, right? It's more like BitTorrent. It's sort of distributed and it's out there. And basically, all the nodes form a peer-to-peer torrent distribution channel. So you just find one of the nodes. I don't know if they torrent it in terms of multiple nodes sending you different bits of it. I don't know what the protocol layer is. But every full node running out there has the opportunity to provide this information to every other node. Again, because they're highly incentivized to propagate all that information as fast as possible. So it's a pretty good self-reinforcing incentive. Okay, one last check.
One last check.
No, it's not there yet. It'll get there.
It'll get there. I want to give a round of applause to Joe. And I'm going to stand next to you because the mic is actually there.
Oh, sure.
So I can
hey, buddy.
be heard on the live stream. So thank you for people watching on the live stream too. It was this pretty good turnout, I guess.
Cool.
Not bad as far as production too on the back end. A little late, but it's okay. Thank you guys for coming. If you have questions for JavaScriptLA, anything we do, you have questions for Joe, you want to see him come back out again another time, or maybe do like more in-depth stuff with him, we can do that. Just give us your interest. The best way to reach us, again, is the Slack channel. Was everybody who's here, did everybody hear about the Slack information? Okay, we also have Facebook, facebook.com/JavaScriptLA. We have a Facebook group, facebook.com/groups/JavaScriptLA. We use that more as a place for people to talk and reach out to us. So use the Facebook groups. We also have Instagram. It's JavaScript Ninja as opposed to LA because we're all over the place. We have an OC group too. And I wanted to just mention that because Orange County is also just as big, starting to get as big as LA. So, we're seeing a lot of people there. And you're also invited to come to Orange County anytime. Cool. And I think that kind of covers it. Twitter, you can find us on Twitter. We'll email you stuff. And oh, by the way, stay tuned on YouTube because we're going to have more things coming out on YouTube anyway. I myself will be on YouTube. And I think, next week, September 29th, we have our first workshop again for JavaScript. We're going to be teaching React. That's with Ben Junya.
Cool.
He's a very popular guy on our Slack channel, and he had a meetup that was done in March, which had a significant turnout too, over 100 people subscribed or RSVP'd for that meetup. So it was on ES6. So you definitely want to check that out. Again, it's on Friday. Details on the meetup page, Eventbrite page. If anybody needs information about that, see me after this meetup. And then the next one too, maybe you can raise your hand if you're here, James. Or if you want to come up here just real quick and introduce yourself too. we'll have a meetup with James Earl from Microsoft. So that's going to be fun. He's going to be talking about TypeScript.
Next week. Next month.
Next month. So yeah, stay tuned.
It'll be right here.
Come up here, James.
Sorry.
Yeah, so you can see you. Yeah.
Oh yeah.
So yeah.
Speaking of the microphone.
Yeah. So yeah, October 16th, right here in the hackreactor, I'll be speaking for JavaScriptLA on an introduction to TypeScript. So be there or be square.
Exactly. So and last thing here, I guess. Again, if you have suggestions or comments or things you'd like to see improved, let me know. You know, Daniel there, he works really hard. Let him know. Let Joe know you have any feedbacks for like today's presentation. We'd love to hear from you. We'd love to improve this. We thank you guys for supporting us, and see you at the next meetup.
Yeah, thanks a lot. Yeah, thanks for the chance. Feel free to send me an email if you have any questions. I'm very accessible, and we can see on our block cipher it was apparently received. So look at that. I'm richer. I got more fake Bitcoin. The wealth is overwhelming. Thank you all for coming. Yeah, Joe, Andrew. Actually, do you want a card? I don't have a pen. So it's on the slide here. So you can get it. Let's do that. And it's the last one. It's really slow.
Yeah, right?
I guess it was, I probably could have done Control-N, right? So, legendary requirements or the shorter version, both will work. /pres, Bitcoin JS, LA, and then either of these two.
Alright.
Feel free to write it on the card if it'll help.
I can do it right now. Said you like the food. Fan of sushi?
I am, yeah.
What? I am actually an ex-sushi chef.
Are you really?
Yes, I am.
Oh, hey. But not anymore.
Not anymore, because
But do you know a great sushi place?
Yeah, the first place I used to work at on Oxford 6, and I'd love to take you there if you...
Oh, I'm totally up for that sometime.
All right, sure. So
yeah, send me an email,
right.
And we'll have to figure out when I get down to LA, but that would be fun.
Awesome, all right.
Yeah.
Thanks.
What's your name again?
Jay.
Jay.
Real name's Jeff Clintus, really hard.
Right. Cool, well send me an email, Jay.